This episode of the Design Your Dream Home podcast is brought to you by CRAN. CRAN is the Custom Residential Architects Network, and by Porcelanosa. Porcelanosa is a luxury lifestyle brand that brings modern European design into your home. You are listening to the Design Your Dream Home podcast with Doug and Steve. Doug and Steve are architects, and they're here to help you design your dream home.
Well, I am real excited to have Laszlo Kiss as a guest on our podcast today. I know Laszlo very well from, his former partner, Simon Ungers, was my teacher as an undergraduate student, and I really liked their work. They were based, I think, in New York and Ithaca at the time, called UKZ, and just really was always really admiring their works. And much later on, they went off their separate ways, and Laszlo created, I think, his own company, Studio Kiss, and then also now the ASAP House project. So Laszlo's been involved in many different sort of areas, which have always been really of a lot of interest to me: green design, modular design, modular home design, and so on. He graduated from Cornell. I think after that went to SOM, has taught a lot, and then created his own firm. So he's always been an architect that I've always admired. So Laszlo, thanks very much for joining us this week. I really appreciate it.
I'm glad to be with you guys. Nice to see you again. Nice to meet Doug.
Good morning, Laszlo.
Good morning.
So we can go a lot of different ways with you, but maybe you can give us a little bit of a introduction to who you are and where you came from, and then we can get into some of your more recent efforts. Sounds
good. So it's funny, but I have to start back in like 1980.
Okay.
And we were green architects from Cornell, right? And stayed in Ithaca. My partner Simon was teaching at Syracuse. I was sort of running this office in Ithaca. And we got a project for an art historian who's actually rather famous today. His name is Robert Hobbs. He's at Yale now. And we built him a tiny 850 square foot house. And it was a passive house, and had a wood stove that was heating it. It was 15 degrees to southwest, so it was solar south, buried in the ground in the back. But a very unusual house because it was our thesis in essence, and that was the start of our interest in green design. And there was some green design in 1980. I shouldn't say we were the only ones because there was the zeitgeist. I think Carter had just put panels on the White House. So people were thinking already. And then we did this project at the same time. So we had this little 800 square foot house. And then we had this globe on the roof of the Pan Am building because after the crash. So this was a redevelopment of the Pan Am building. It was a pie in the sky project. We had a client actually for it. And then actually utilized a double shell skin, so just where you could take the heat from one side and circulate it in this sphere. It was a sphere. So the idea was that we were going to utilize the heat cooling effect, convecting, all sorts of stuff. So that was actually really forward thinking at the time, with a shade system that would sort of follow the sun. I mean, photovoltaics were not in our wheelhouse at the time, but today you would be doing those. And actually, some of our classmates recreated that inside the Rose Center at the Natural History Museum, because that's our globe, essentially.
Oh, I see.
I was actually even told that. Hey, we built your globe. And then, we built houses, and it was mostly just stacking wood together like the American way goes, but always learning. And we had a client upstate New York in the early 90s who had sort of done a modern house, lovely modern house, but building upstate New York in the 80s, trying to do modern anywhere, it's very difficult.
Right.
Because building is really a marriage between the client, the contractor, and the architect. And if one of those falls down, you have a problem. Either the client bags out on you, then you can't complete the thing right. If the contractor is not capable, it's not going to be completed right. So you can have a great client and a great contractor, a bad architect, and you have, again, not a really, I don't mean not a good product, but architecture is more than just a house where you put your stuff. So if you subscribe to that architecture with a capital A, it's an environment where you live, then that's what we're talking about here. So this gentleman, Ron Smith, wanted to build this guest house. And we found this really interesting system. I found it. And at that time, it was Zweigart, UKZ was Unger's kid Zweigart, and Simon had gone off, and then Todd and I continued our office, Kiss and Zweigart. And so this was called a 3D panel. It's still around, and it's utilized around the world. It came out of Austria, and it's a really cool concept. It was a styrofoam core, high insulative value styrofoam core, with a metal mesh on either side, and then the technology was really tying the meshes on either side together in a truss-like manner with wire, welded wire. So you had very little transmission through thermal breaks, and then you would spray, and you would use gunite, which at the time gunite was not as well used as today. Like pools out on the east end, you'll use gunite, but in that gunite in the early 90s was mostly utilized on highways and stuff. And so you would spray 1.5 inches of gunite, so you had great thermal mass on the inside, great thermal mass on the outside, not broken, and you could create this really cool house. So we actually built the house. Honey Rashid's parents bought the property and live there now.
Really?
And but anyway, so it was a learning curve working with this 3D panel. So that was my first foray into sort of prefabrication of sorts, right? Because these panels were partly prefabricated. It was not the standard construction. And at the same time, we were also exploring modular because there was more property that Ron had around him. And we thought, maybe make a little development. We built some houses. And I thought, hey, let's do a modular. Modular would be really cool. So I started thinking with a box in my head, 15 feet wide, 64 feet long maximum, and about 13.6 high with the wheels under it to get under the bridges. And then that sort of went away. That project didn't really materialize. It sort of went away. And in the 2000s, after 9/11, 9/11 destroyed my office. It was across the street from the World Trade, so that created all sorts of headaches for us. My family ended up moving out to Quogue, and we ended up moving out to Sag Harbor and wanted to build a house. And this was 2005, 2006. And $300 a square foot bought you bare minimum. You want the wheel with that? You want a steering wheel? That's how the discussion went. So $300 a square foot for a 2,500 square foot house, like 750, 800 plus land, which was another 500,000, 600,000. You were like in the millions, right? And I'm like, we can do better than this. And so I think I designed 24 houses trying to figure out how to get something in the $200 range, $225 range. And in the process, I met the people from WeHouse. And Jeffrey and I started talking. I said, well, hey, you guys could build me this and I'll design it. And they said, well, you're an architect. You don't really need us to design to work with us. We're in Minnesota. We're using Simplex in Pennsylvania. Why don't you just I'll introduce you. Just go to Simplex directly. And that's how I built my first modular. So I went to Simplex.
What is Simplex?
Simplex Industries.
Yeah. In
Scranton. They're a pretty good modular manufacturer. They started out as a plumbing company. That's why they call it Simplex, because they made I think some heat exchanger boiler or something. That was really what they were doing. And then they I guess that boiler business went away and they became a modular home manufacturer.
Wow. What an amazing story.
And so we built a house, a 2,500 square foot house with Simplex. It was delivered, and then I learned about superior walls, and so you use superior walls. as a foundation. And literally that house, I Simplex had already manufactured the modules, which I wasn't very happy about, but they thought, hey, let's go. But Southampton is very slow. So we didn't get approval till like November, end of November. Uh, and literally November 5, we started demoing the house on the property. November 26th or no, November 20th, they started digging the foundation. On 27th, and these are like shortest days of the year, like we have no late daylight. We brought in the superior wall, laid down 100 and I think it was 100 and almost 200 feet of foundation in one day, with like 2 panels missing, 12 feet missing. So we laid down, 180 some feet. The modules were dead at night. Literally, they finished the foundation, put on in the morning at 6 o'clock, whenever 7 o'clock, when the light came out, put on the top plates and hoisted in the modules. So literally, like within 20 days or less than 20 days, we had demoed a house, put a foundation up, and put the modules on top of it. It took us about 2 or 3 months to finish it because there was a lot of things we were doing on the inside and whatnot. But that house ended up, for its time, using it didn't use any carbon fuels. It was utilizing geothermal for heating and cooling. The pool was solar heated. It had 10K photovoltaic panels, so it created half the energy on site. I think it was about $1,500 to $1,800 a year to run that house, and that was running a pool with a very.
That's amazing.
Okay, and that was in 2008. And it wasn't it was no passive house quality house, and that house, still is doing well. So that was my first experience. And we did it for probably $2.25-ish, $225 a square for two. And that was with the photovoltaics, which were expensive in those days, even with the subsidy. And landscaping. The pool was there, so we just refurbished the pool and stuff like that. But it was a great experience. And then I had started this company called ASAP, and thinking, hey, this is actually really cool. I can do this with other people, and we can make a bunch of models and then customize them for people. And I didn't expect 2 things. One is, small, efficient houses are not in the wheelhouse of American public, or at least they were not 10 years ago. Not in the Hamptons. People were like, we want 5,000 square feet. How many people do you have? Well, you have a baby and my wife and I. And like I'm silly. I would say I'm silly, not stupid. I'm silly. I was like, why do you need 5,000 square feet? We really don't need 5,000. And people would tell me, why are you doing that? Just do the 5,000 square foot house for them. But it feels wrong. This is the big dilemma of an architect. If you're socially conscious, a lot of times it just feels wrong to do some things. And you're dependent on your clients and their whims and their friends' whims. We did a house in Remsenburg for a client. It was a really beautiful house, not super expensive, but a very custom house. And one day I show up at his house and he's freaking out and he says, my house looks like a hotel. Everybody tells me my house looks like a hotel. I'm like, what do you mean it looks like a hotel? Well, it just looks like a hotel. Everybody comes here and says it looks like a hotel. And it took me like a while to figure out that the people coming to his house had only seen high-end custom architecture when they went to a resort, right? And they came to his house and they associated that with a hotel. So you encounter all sorts of wild stuff from people and their friends and whatnot. So back to the modular. Size was an issue, and then the market crashed, and building stuff was very hard. So that went away for a long time. And then recently we started getting projects and building modulars, and we did that house in East Hampton, which looks great. We just finished one upstate in Newport. There's another one in Montauk and other ones around. Architecture is a slow process. You meet somebody, and then 10 years later, you build a house for them. So things take time. There's a bunch of clients who, next year we'll do it, or this year we'll do it, and then it becomes next year we'll do it. So that's my story.
Can you list off some of the kind of benefits of modular versus, let's say, more conventional approaches? Why is it what you're doing besides the cost? Maybe it costs
So
less.
there, cost a is an issue that you're always fighting, right? Um, so time, quality is what is the troika, right? Time, quality, um, and what's in it, right? Like the worth of the object, right? So I think with modular, what you end up getting is,
Oh, it's cost, quality, schedule.
yes, thank you, time, yes, that's what, yeah, yeah, cost, quality, schedule. So with modular, schedule in terms of time, you can actually expedite it quite a lot. It's getting a little bit more difficult because the states are getting very difficult in terms of approving projects. So the approval process up front, like in Montauk, and we're going to have a year just local approvals, for example. So that's not useful necessarily. But once you get the factory going, they take 2 weeks to build a house or less in the factory. And if you can be prepared on the site, you can shrink a fairly custom house from 9 months to a year on a typical site process to probably 6 months to 7 months, and time is money. So that's one place that you can become more efficient. If you're working with the right factory, and that's always a trick, right? Factories vary far and wide. But if you have a good relationship, and that's what I'm doing, is meeting people and trying to work with factories and relationships, you end up with a very quality product. And when I mean quality product, the way they have to build to get a house down the road is actually a little bit different than the way you would build on site. They're very efficient in the factory. Their waistline is much smaller than a site build. They don't just randomly cut 2x4s and somebody just picks up because they need a piece here and they throw away the other piece. And the waste stream is really controlled. They literally make which architects, as architects, we don't do this because it's not our responsibility. But for example, they take every wall and they create a diagram for it with a cut sheet next to it, itemized, figured out how it's efficiently cut out of lumber. And that little sheet with a diagram showing exactly how that wall is then put out into the factory. And the factory is like an assembly line, right? It starts out with the cutting guy, and he cuts all the lumber for this. And he puts that little diagram, wraps it around it, sends it onto a table. It's assembled into the wall. Meanwhile, a floor is assembled. These are lifted on top of it. So you also work from the inside out in a factory house. So in other words, you don't sheathe like on a site. You would build a frame, you would sheathe it, and then you sort of work inside, and then sheetrocking would be the last. In a factory, the sheetrock actually is put on first. That goes onto that wall, and it's glued and screwed. So everything is glued and screwed. So it's actually probably less popping and recall after movement on site, for example. My sister lives in a William Turnbull house, and that house is still popping nails. And it's 1973. It's a great house, but there's a lot of movement in it, So I think you're getting this quality, as long as you know what you're doing. I was actually just writing a response, a comment onto a modular website, as you guys called, because there's this battle between the architect and the contractor of this. And it's even a bigger battle from the modular side because it's actually a business of pre-made stuff. So custom in modular is more unusual, right? And a lot of people say on that end, on the factory end, oh, architects don't know what they're doing. They just spec all sorts of crap. It's terrible and whatnot. And my analogy is, just because you have a license to drive a car doesn't mean you can drive an 18-wheeler. Right. And essentially, it's the same thing with modulars. You have to learn what that is, and then you can make something really good out of it. And that's what I've managed to do. So you have to have experience. And I feel that I can work in a much larger sphere. So from East, I'm sitting in Morristown, but I'm doing something in DC, in Montauk, upstate New York, because I'm using a modular. So I can actually take my designs through DD. Factory creates the working drawings, which are localized. And then with a good local contractor, you install that. And this is actually more akin to the Japanese method, right? The Japanese architects don't do working drawings, especially on a larger scale. What they do is they do high-level design development drawings. I learned this a long time ago, and I was like, that's how we should be doing this. Because what you do is you end up doing things 3 times. You do a design, and then you do a set of working drawings, and then a budget comes in. The first house we built, right, was $28,000 for the house cost $28,000. But we designed it 3 times because first time it came way over budget. The second time you bring it down to budget, and so you had to redraw it, and then you had to redraw it again for some other reason. And then when you're building it, the contractor says, well, that's not how I build it. So then you have to rethink it again. So unless you have the benefit of a lot of budget and a contractor who is really more like a general, more like a owner's rep who oversees a bunch of subs, and you can really bring a lot to bear, that's something else. But on a residential scale where you're building small budget, small stuff, it's very tough. So I feel that the factory making the drawings, the final working drawings, from my DDs and me understanding what the process is, it's a great way of working. I don't charge a huge fee that I would, not a huge fee, but I don't charge my full fee that I would in a typical instance where I would become the architect of record. This way it's the factory actually stamping the drawings, not me. So I think the client gets, I like to say, a architect designed, efficient, timely house. So if you're ready to go and do a really high-end custom house on a small scale, then a module is a great buy.
So this is really challenging for me to understand, the idea that you can do a modular home that's custom. So I've got a lot of questions here. So has it gotten easier to be creative with modular over time, or how does all of this work? How do you do custom homes if you're using modules, or you're not using modules, you're just using the construction type for modular housing?
Great question. So modular is nothing more than taking a house and creating and reducing it down to a set of boxes that can be moved down the road, right? So if you have a typical center hall colonial, let's say, right, that's 28 feet or 27 feet deep and 60 feet long, right? That would be cut into 4 boxes, right? 2 on the ground floor, 2 on the upper floor, right? So that's a very simple way, and that's what most modulars are. They're like typical houses that are built on site, but just modularized. So as long as you don't have super large spaces, you can. There's ways, if you understand the process, you can create them. I actually, what I call I'm a hot rodder. I hot rod Amish construction. A lot of the factories are down in middle Pennsylvania. A lot of them are working with Amish. So what I do is I hot rod Amish construction. I've actually worked with these guys in such a way that we don't do lintels over windows because we don't have to, because you're using the floor and the ceiling, because every box has a floor and a ceiling. So you actually end up with a double floor ceiling in the middle, right? So instead of having a 12-inch floor, you end up with 20-inch floor, because 2 10-inches on top of each other. That's the only real oddity. And that's how you can tell a modular house. When you walk between the floors, if the floor is really thick, you know it's a modular. But anyway, so because you have this double floor ceiling, the windows you can go to the ceiling, which allows light to go much deeper into the space, because the proportion of where the window is, how far it goes in. So so you can take advantage of a lot of the construction and create what you want to create with it, right? So there are limitations, but for a small house, they're not that huge. You can create, and when I say custom, meaning the floor plans that they have, you can take to, most people would say, okay, I can take their floor plans and try to nudge them around and work with them. Or you can just come in with your own plans, and that's what I do. I have an understanding on how to work with these boxes, what the limitations are, and then I create a set of plans that I feel are efficient, meet the client's needs, and does that answer the question, I guess?
It does. It does. So what do you do with things like windows, for example? So you got a floor to ceiling window in a modular home. Who's making that window?
Well, so different factories have the reason factories are efficient and the prices are maybe less than you would have on site is because they buy in bulk. And everything in this world is about how you negotiate prices on the wholesale level, right? So if I go into Lowe's and I buy a window from Lowe's, that window is probably not the standard Marvin. It's a Marvin that's made for Lowe's, and it probably has some efficiencies in it, and probably it's a little bit lesser product than if I buy an architectural grade one, because Lowe's has negotiated a price to buy 1 million windows with this spec, right? So factories work the same way. They know they will do 300 houses or 200 houses. So they will negotiate with Marvin, they will negotiate with whoever else, that they will buy windows for these houses. They will not buy them ahead of time because they don't know what the windows are, but they make a commitment letter. So Marvin knows that I'm going to be selling these guys all these windows, and they will be coming in bunches. The paperwork is streamlined. You're not dealing with 10, 15 customers or 100 customers. You're dealing with one customer. So the whole payment process, everything, so that reduces the price of that product. So as long as I know what windows we're working with. The house in East Hampton, we use triple glazed windows. And actually, that was a SIP house. So we actually use SIP panels instead of regular walls in the factory. So that's actually a SIP structure. A hybrid SIP structure, because it still has to use the floor and the ceiling the same way, but the walls were SIP walls. So
you'll probably explain to explain that term.
Oh, I'm sorry. So SIPs are structurally insulated panels, and a typical wall contains about 25 to 28%, and that's on a good side, solid wood. And the solid wood has very low insulating value, and it creates thermal breaks in a wall. So if you have a wall, 30% of it is R5, even if your wall is R10. So the combined value of that wall is reduced.
Right.
So people have done many things. They put studs on 24 inches on center because they can line up the joists coming on 24 center. So that's called advanced construction, whatnot. But the really good way to go is go with SIPs, which eliminate almost all that timber. And now we're talking a continuous insulating value that's the same throughout the wall. And it came into, actually, I think Frank Lloyd Wright created the SIPs. They were called stress skin panels. And essentially when the plywood came into being, Wright started using them and created these stress skin panels back in the 30s. And then there was the Forest Research Institute that said, oh, we can increase the use of wood. So they promoted the whole stress skin panel. And then in the 60s, there was a gentleman who then added the insulation into it. And then in the 70s, it sort of started taking off. But it didn't really take off until you replaced plywood with oriented strand board, because now the sizes could change and CNC machines came in. So in the late 90s, the stress skin panels became much more viable and flexible. And then OMG, which is, I think, magnesium oxide boards replaced, which are fireproof, replaced the wood. So now these are fireproof potentially. We actually even designed a prefab townhouse using OMG board, SIPs for New York City, and didn't get built for many reasons, but it basically could have been built. It would have met the code. So anyway, so the East Hampton House is SIP, for example. So that's taking material that wasn't readily used in the factory, but this was building professional building systems. They're all in the center. They're all like in the middle of Pennsylvania, and so we did a SIP house. I thought that was really cool, and it uses minimal heating and cooling, and that's the house that you were referring to earlier, Steve, that you saw the pictures of in August.
Yeah.
This episode of the Design Your Dream Home podcast is brought to you by CRAN. CRAN is the Custom Residential Architects Network. CRAN is the leading resource and voice for architects who focus on collaborative design with homeowners. CRAN provides support, advocacy, and education for custom residential projects, as well as professional development for its members via forums, symposia, publications, and local activities. To learn more about CRAN, visit www.aia.org/CRAN. This episode of the Design Your Dream Home podcast is brought to you by Porcelanosa. With 30 showrooms in the United States and Canada, Porcelanosa is a luxury lifestyle brand that'll make your next project's dream into a reality. From a wide selection of tiles and mosaics to modern bathroom and kitchen cabinetry designs, Porcelanosa makes it easy to bring modern European design elements into your home. Visit porcelanosa-usa.com to learn more.
Can I ask you a question? Because I've had this issue now, because I've tried, and I don't have the experience you do in modular, obviously, but the challenge was not, I mean, I love the idea that the building is built in the factory. I think that there's all these kinds of things that I really like about it, the cost and all of those things. The issue was the contractor, finding a local builder that had the experience with this type of work. And also because a lot of their contract is diminished by having it built in with a modular company, meaning all they're doing is basically kind of taking the building and putting it on its site and doing some finishes, let's say. It's not that attractive to them. So it's hard to find, for me, it's been hard to find that person that's willing to sort of be half the contractor, not the entire job. So they always say, hey, listen, I'll do the job, but I want the whole thing, and it's better for me to do it that way. So it's kind of a challenge. So do you encounter that kind of thing?
Bingo. So the first house in Sag Harbor, I was my own GC.
Okay.
I contracted with the factory as the builder. Okay. I took the responsibility of the builder. And then I hired subs to do the work. So I was essentially a construction manager.
Yeah.
I became my own builder. That's not really realistic, as if you want to do multiples and all over the place, right? Mm. So what I actually ended up doing is about 10 years ago, I met a gentleman out of Rhode Island who does buildings up and down the East Coast. He's a modular builder. He was an engineer. You got into this thing. He liked SIP. So that's how he did the SIP house, because he was a real SIP proponent. And he's out of Rhode Island. And so what I do is I actually don't contract directly with the factory anymore. What I do is I contract with him. He will take the responsibility of delivering and setting the module. So my clients have an agreement with me. I oversee the whole process. I help them with the design, facilitate the factory and all this. Then once we have a design, but the whole process of pricing. So I'm going to bring this in now because I think will be very valuable for your listeners. In a typical scenario, you and I will design something. We would go out to bid. We get a price, but we put a lot of effort in. You have to have a full set of drawings for that price to be accurate. Otherwise, it's just some budget, right? In modular construction, we can create a schematic design, give it to the factory, and knowing what we know, what the factory knows, what their specs are, and knowing what I'm requiring, I don't have to do a whole set of working drawings. We can get a very accurate price for the factory cost, which will be 60%, 70%. Depending on what we're doing. So the client upfront with not a huge cost can have a real number in their hands. And this is where my associate or my partner, it's not a partner really, it's just it's a modular home guy that I work with who works all over, and he buys more than just modern houses that I do. So he has a better buying power
Okay.
from the factory. So I work through him. So my clients sign a contract with him through to the factory. He will then oversee and set the product onto the foundation. And then we end up getting a local contractor, which I go out and I bid once we have the drawings from the factory, plus my additional drawings for siding and other things around decks, whatnot. And using Superior Wall, again, you have a Superior Wall will go in and they install their own product. So they have their own crane, they do everything. So you take that burden away from the local contractor. So the local contractor really becomes a finished contractor.
Yeah, right.
Siding and stuff like that. So this way, breaking up the process, you don't have too many cooks to blame people. Because that's what happens when you have too many people who nobody's singularly responsible. Then people point fingers. Oh, they did it wrong. That's why it doesn't fit, whatnot. As long as the modular contractor is responsible for bringing it in, fitting it on, I know that Superior Wall foundation will be within a 1/4 inch. And it's insulated. It's ready to be used as an insulated, buildable out basement or walkout basement or whatever. We have 75% of it, 80% is already done on site, and then the site work from that point on, and finishing inside, connecting. These houses are so efficient now that we go to mini splits, which then we just install on site. That's a little bit of a funny thing. Sometimes factories don't want to put in the tubing for it, but
you're gonna have to explain mini split too.
Okay, sorry. So mini split. So I think one of the problems green architects are coming, or energy efficient architects are coming into is that a lot of the products out there are made for not as efficient houses. So everybody's used to an air conditioning system that has a big ductwork and it's got this big unit outside and it's moving air around constantly and all that. If you have an efficient house, then you don't need all that heating because you're not losing all that heat, right? So you need smaller equipment, and you realize that ducted systems are too big. So mini splits are essentially a system which throws away the ductwork and it creates localized heating, cooling units, which are quite small. They could fit into the ceiling. There's ceiling cartridges that are on the wall. People who travel around the world will see them because most of the world actually utilizes them. It's like a suitcase size, a large suitcase size exterior unit that is the heat pump, and then the inside units are the conditioners, the dehumidifiers and moving the air, heated or cooled. And so the house upstate, for example, 700 square feet, I think utilized maybe 3,600 or 4,200 BTUs a unit, So it's very little heat.
So what does that come down to in terms of cost to run a small home on a yearly basis? Are we back to like $1,000 or $1,500 a year?
Yeah. And actually, the codes all require houses to be that efficient now. I mean, the new New York City Energy Code essentially requires a super efficient house. So the house up in, I was really happy to see that the house in New Paltz required a blower door test. A blower door test is essentially,
wow.
Yeah, as to get the CO. So you have to prove that you actually built the house based on the required specs. So for your audience, a blower door test is you take off your front door and you replace it with a large fan that's hooked to a computer, and you you do two things. You can blow air into the house or suck the air out of the house. And when you suck the air out of the house, it's like a balloon, right? It starts shrinking. right? So if there's holes in that house, then you can start sucking air in through those holes. The computer will measure the airflow at the door fan. So it knows that it should slow down as it starts sucking the air out to know how much air is infiltrating in. And you have to meet a certain threshold. If you have a lot of holes, I think a while ago, a friend of mine had one of these things, and my mother-in-law had a very nice house built in around 2000, and we said, let's do a blower door test on it. Let's see how efficient it is. And we did, and essentially came away with that there would be a 40 by 30 hole in the wall. So, I mean, you wouldn't leave a 40 by 30 hole in the wall open all the time.
Right.
And essentially that was the equivalent. It was broken down into small things, but that was the equivalent. So this house in New Paltz, I think it had, I don't have it in front of me, it was like 2.5 ACH, I think, or something like that, 1.75 ACH. I mean, it was ACH meaning air changes an hour, you know. The guy who tested it said, God, you guys, he didn't say it to me, he said it to the builder, but the builder really wasn't responsible for it, but he got the credit. He goes, you did a really efficient house there. I'm like, thank you. He didn't really, wasn't as responsible for all the efficiency of it, but he got
So that's kind of scary, right? Because if you're with a building, usually you just give the keys, say the house is done, everything works, the lights work, everything, the electricity is working, it's fine. Now you have to have this extra test. Right. That if it's not working, I mean, these are things you can't necessarily see either. It's not like big holes in the wall, just little cracks here and there. You have to go around and finish the house, right?
Well, yes, but you anticipate this. Yeah. So, and with the modular, I was actually scared because, gosh, I don't control everything. And I know where you put this up. I know Saki, the modular contractor. I know he's diligent, and I know he went and he filled everything foamed and all that, where the modules go together, because that's really the biggest issue.
Yeah.
But I was sweating bullets, but and I was so pleasantly surprised that yes, we did it. But we anticipated it too. So this is a hybrid wall. It's not a SIP wall. It's a 2x6 wall. But we sprayed 1.5 inches of foam on the outside sheathing, and then put batt inside of that. So what that does is creates this hybrid wall. So you seal all those little holes with the spray foam, and also isolate the sheathing so you don't have moisture build up on that and all that, and you're getting a higher value in the insulating value in the wall. So you anticipate the leakage happening, and you reduce it. If you're building this on site, then what you do is you do the blower door test once you are enclosed, before sheetrocking and all that. So if there's issues, you can address them before the house is done, and then you have to go try to retrofit. There's also a cool product that I heard that you guys might be interested in. It's like a micro glue that you essentially you pressurize the house. And obviously you can't have sheetrock on a wall, but you pressurize the house, and then you release this glue, and it sort of goes and fills into all these holes with the pressurization. So you can actually have some holes, and if you have to get rid of it, there's this interesting product that will plug up those holes.
Last year I visited a modular company up the Northeast called Bensonwood. And just watching them put together one of these houses, you come away convinced, because the guys are working in climate controlled, good lighting, 70 degrees, there's some music, it's very comfortable. And of course they can do everything beautifully. And then like an assembly line, there's an inspector who comes around, he checks off, you did this right, this is right, that's right. Contrast this with on-site guy. It's cold, his hands are freezing, it's windy, he's sitting up there, it's like, forget it, that's enough screws, right?
Yeah.
that's the reality of construction
company
on site, right?
Yeah, and actually, they're not modular, they're prefabbers.
Oh, okay, got it.
Right. I don't mean to be stickler, but
No, actually, please be a stickler on that one. That would be good to.
Yeah, explain the difference to
so the
us.
difference is a module is actually a completed box, right?
Okay.
And a prefabber is more that you prefabricate product. Like window is prefabricated. We don't build windows on site. And we're used to smaller elements being prefabricated, and we respect them. Benson Wood is one of the people who breaks the building down into components, meaning big wall sections. And the wall sections could be huge. Like it could be the whole side of the house on the first floor. And they will put the window in it, wire it, and then those big components come out and then are assembled. And they are just super high quality because they're going towards passive house. A lot of their stuff is passive house level. And I'm actually very interested in that whole component aspect. I don't know if you guys looked at that USGBC approved continuing ed lecture I sent you guys. I sent somebody. I don't know.
You sent somebody, not to me.
Maybe it was your assistant or your producer. But anyway, I did this 2-hour long continuing ed seminar for a Cornell friend who runs these continuing ed seminars, and did about half a dozen of them, and then gave it to some AIA groups. And it talks about modular and prefabrication, and specifically targeting sort of modular SIPs, pre-stressed concrete, or not even high-strength concrete, like Superior Wall, for example, which is utilizing a very high-strength concrete, and it's thermally broken and does all those things. And how you can utilize these to create a really energy-efficient house. This morning I was talking to a friend, and she was saying, well, what are you going to talk about? You have to talk about energy efficiency because its time has come. And I said, yeah, we always think its time has come, but thank God the codes are pushing us into it more. Right. Because even if you look at the USGBC, the green ratings, energy was always very low on their interest. Everything else was almost more interesting than a low energy house, right? And passive house is phenomenal. It doesn't work as well in the Northeast, I think, as it does in a lot of other places because of our moisture. You still need to get the water out of the air. So in Germany, you can have a passive house and you don't have to worry about the moisture. In the Northeast, you have moisture and you have to get it out of the air. So you're going to have to use some air conditioning. And that's why mini splits are really useful and all that. But that's the biggest issue to me. And then again, you need a good contractor, a good architect, and a good client to get a passive house built. It's not just a simple thing. I want to do a passive house and we do it. Like we said, the code is requiring now, to do these testing. Well, passive house is even orders of magnitude above that you have to prove that you're actually doing and what you said you were doing.
Right.
But if you can come close to it, if you can do 80% what passive do, then you can have really efficient product, a house that's worth, living in and leave, and being proud of that you're not contributing to the waste of the planet. There's interesting code anomalies, and I'm not quite sure if this is interesting to your audience, but for example, the town of East Hampton introduced these additions to the New York State Code, right? And they require certain levels of HERS rating. HERS rating is a rating of a house that sort of looks into energy use, essentially. And you have to meet a certain level. And I think it's 42 and 33, depending. If you have a smaller footprint than 6,000 square feet, I think you have to be at 42 hertz. And then if you're larger than that, you have to be down to 33 hertz. And the way it's almost impossible to do a small house under those conditions. It's very difficult. Like to do a 1,000 square foot house, your base energy use, your refrigerator, your all these things will be using the same amount of energy as in a 10,000 square foot house, but it's distributed over 1,000 square feet. So to meet, you actually almost have to use no energy anywhere else because your refrigerator is using more energy than anything, right? So these are like weird anomalies. We want to have a great code, but then we're excluding making small houses and benefiting big houses because they can put photovoltaics on and then get the benefit of that, and they have the room for it, and you don't even have the room on 1,000 square foot house. So it's a confusing landscape, and it's a confusing landscape for a client who wants to do something interesting, wants to, live in a house that's comfortable but also sustainable.
Right.
And I'm sure you guys encounter this every day as well.
Interesting. I'm interested to hear a little bit more about photovoltaics. Do you end up using them a lot, and have they changed and become more efficient, easier to run? I understand they've got to be cleaned.
They do. They have to be cleaned. I used to go up on the roof of my house and essentially wash my photovoltaics
right
every so often.
Right.
And it impacted my installation. Mine was now it's actually 12 years old or 11 years old. And in the old days, and this is the advancement you were asking about photovoltaic, those panels produced about 200 watts per panel. And the panels were like 48 inch by 30 inch or something. That same size panel now produces 350, almost double, twice as efficient, like 350 per watts per panel. My panels were two series of, I think 20 each. So 20 and 20, two banks, right? 20 banks of 20 and 20. And they came out to 5K and 5K, so 10K. And each one of those banks went into an inverter because you're creating direct voltage out of the DC voltage, out of the panels. And then they go into an inverter, which then makes it an AC. Alternating current, right? And then that's then tied into the grid, and then it actually shuts down because when you're grid tied, and grid tied is meaning that if you're not using any electricity in your house, the energy you're producing is running your meter backwards. So essentially energy is flowing back out into the grid. And then when you turn the light on, energy, either you use whatever you're using on your end, and if you're using more than you're creating, then energy will flow back. So you have this in and back and forth energy flow, but that also makes it dangerous for the grid, because if the grid goes down and you're producing energy and you're putting electricity in, it could, you have to be able to shut down the grid. So that means your electricity is shut down on your end. So you don't have you don't have the benefit of your panels in case of an outage, unless now you create additional circuitry where you can, but then you have to balance your load, right? Because you can't make more energy than you're using. So it becomes very tricky. So you really need good batteries. Now we have good batteries, so we can do that. So now going back to the panels. So today, not only are they 60% more energy efficient per square inch, but they also have a mini inverter on each panel. So the benefit of the mini inverter is if that panel goes bad, or it's shaded, or it gets dirty, or broken, the whole system does not shut down. So if one of my panels was reduced to 20% production because of a shadow hitting it, every other panel went down to 20% production because they all had to produce the same amount. So I was wasting a lot of energy potentially. And I know because there were some shadows at certain times of the year, especially in the fall when the leaves are on, you're having some shading, and that shading diminishes the potential of the system. And all you have to do is look at the production. In the spring, your production is much higher because there aren't leaves around. Right. So having the benefit of these mini inverters, now each panel produces whatever it does, and then it sends it in and adds them up together. So some panels might be 100%, some panels might be 20%, but they're all individually producing. If one panel goes bad, then the rest of them are still producing because it's isolated. Inverters are still the most tricky aspect, and are the biggest chance of going bad in the system. Photovoltaics don't go bad. They last I don't know, 30, 40 years, whatever they are, what the life cycle might be. Inverters can crash and burn, you know. And then if your inverter crashes and burns, then you're out of luck. And then you have to wait for another one, so you lose production. This way, you're just changing a small mini inverter on the back of a panel, or you're changing the whole panel, maybe swapping it out with a new one, and they'll change the inverter on it afterwards, or whatever the process may be. So that's the efficiencies. I have not done a lot of it lately because basically you need client interest in this. It's actually unfortunately it's still a game of tax benefits. Somehow people don't see the intrinsic value unless there's a tax benefit. I mean, you know, this will pay you. In a lot of places, a photovoltaic will pay itself back in like 3 years, right?
Wow.
4 years. Yeah, if you're in the right spot and you,
Yeah.
but it's still paying up front. It's like the old adage, I'll give you 20 today versus 30 tomorrow.
Right.
And everybody takes the 20 today. And that's how it is with photovoltaics, you know?
So what about an average colonial home, 2,500 square foot, got lots of sunlight? If I put these panels on my roof, is that going to run my home? Am I going to get enough energy to run the house on a daily basis?
I am not an expert at this.
Sure.
I would say there are a lot of good photovoltaic professionals out there who will come out, who will, so they have a sphere, which essentially they use to see shading, right? So they can go up into the spot where you want to put it, and they can tell what the sun exposure is.
Okay.
Where they can calculate the efficiency of that system.
Yep.
Then they can tell you whether your roof is old enough, like you might have to replace your roof because you don't want to put this onto a very aging roof.
Interesting. Yeah.
That's another issue.
Yeah.
If you have shingles, like cedar shakes as roof, that becomes another issue sometimes because you can have rot and whatnot. Because now you're not burning off the sun is not burning off the water off of it. So there's all sorts of, there's little issues, but I know the issues. I'm not a professional.
Sure.
I don't do it every day. And they will do an energy load calculation on your house based on your usage. And they're not doing an energy. They'll look at your bills and they'll see how much energy you're using. And then you'll know, based on where you are, based on what the shading and whatnot it is, whether you can put it on that roof, whether the two will balance, or they will come 80%, right? Like this is how big it will be, and it will produce 80% of your energy.
Right. Well, there's a professional to talk to, at least. That's interesting.
And so I think people, if you go to a reputable photovoltaic installer, they have those capabilities. And essentially, that's what you need to know. That you need to know that they can come and they should be able to tell you what the efficiency of the unit will be on the roof based on your exposure and your shading and whatnot and your orientation, and whether it can be installed based on your roof condition and makeup. And then you have your bills. You know you're using X amount of kilowatts in a year. And, you know, in the Northeast, you're going to be producing from March through September is really your, actually, April, May, June is really the high end of the production. Because June is the highest, right? It's the longest sun, the longest day, highest sun azimuth, and then it diminishes after that, and you have a lot more leaves. So as the sun starts dropping, right, in its altitude, you're going to end up with more shading in most places. I mean, you're going to have trees around, and so the effect of those trees post June 21 is much greater than pre 21,
right?
June, just because of the amount of leaves on the trees.
Yep.
This, by the way, is one of the few places where I can say having a flat roof is a big benefit, like I do, because you can use the entire roof for panels, which I've done, as opposed to a house with a lot of gables. Besides seeing unsightly panels on gables, maybe half the house will have good solar exposure, the other half will not be, as opposed to the flat roof where it's all good. So I've got 38 panels on my roof, and that is enough to offset any energy costs.
So Google 22 Whitney Road, Sag Harbor, and you'll see that's the house that I built in Sag Harbor, and it looks like a freaking computer chip.
I don't know if mine is on there. I'll have to check mine as well. So we've been doing this for an hour, so I know we could go for more because there's so much. You have so many different areas of expertise. It's awesome. So, but I think the next step is for the next step is for a homeowner if they have interest. Do you have any websites or resources that you can provide that maybe they can kind of take the next level if they want to learn more about what your projects, your work?
Yes. So I have two websites. One is Studio Kiss, KISS.com,
okay,
which is my architectural work. And the websites are going to be revamped over the next couple of weeks, but they're there, and that shows my past work. And then there's asaphouse.com, which is the modular aspect, and it explains what I just did in a detailed fashion and how you can work with us. One thing I always tell people that there's a real benefit of working with an architect up front, and that's one of the things that we provide is a site acquisition assistance, where for a small fee, which would usually roll into the fee if you work with us, we will assess and do some due diligence on your site with local. You will provide us with the information from your local building authority in terms of setbacks and all, but we can check whether sun orientations, whether the objectives that you want to accomplish, does that site meet that? Are there utilities? Is the utilities runs going to be really deep into the property? Are they going to is there rocks around that you can see on the surface? We're not going to do, geodesic excavation and surveying, but you can tell a lot. I mean, we can tell a lot whether it works for you or not. So, that's one thing that I tend to recommend to people.
Awesome. Okay, so studiokiss.com and ASAP house?
Yes.
.com.
It does look like a computer chip, by the way.
Right?
Pretty cool, man. Yeah, unbelievable.
Thank you very much, Laszlo. It's really great to reconnect, and thank you for doing this.
Thank you for having me. I really enjoyed it.
Yeah, really nice to meet you, Laszlo. Thanks for all the great information.
Same here. Okay. I'll talk to you guys soon.
Thanks, Laszlo.
All right, take care. You've been listening to the Design Your Dream Home podcast with Doug and Steve. If you have any questions or want to give us any feedback on the show, feel free to reach us through our website at thedougandsteveshow.com. Thanks for listening, and we'll see you next time.